So let's give it a couple of minutes, just make sure that all the attendees have arrived, and then we'll get started on this. We'll see a few people beginning to join. Okay, let's begin. Okay, welcome everyone. Thank you for attending this webinar. My name is John Greamer. I'm the Chief Sales Officer at Link. I'm your host today, and I'm delighted to be joined by my colleague Dan Prokopiev, who is presenting Digitalizing Your Factory. Just a little housekeeping before we get started. You'll all be put on mute, and if you have any questions during the presentation, please type them in the questions box in the GoToWebinar control panel, and we'll do our best to answer them as we go through this meeting. And if we don't have enough time towards the end, we'll endeavour to get back to you with answers very quickly. To make this session as interactive as possible, we'll be running polls. Please complete the polls as they appear on the screen. That'd be really helpful, thank you. You'll also find a very useful guide in handouts on your control panel that you can download. And of course, once this meeting has ended, the recording will be backed up, archived and made available on our website at a later date. For those of you that may not be aware of Link, Link provides small to mid-sized manufacturers with effective resource management in a single plug-and-play solution. So today, Link MES improves the effectiveness of more than 10,000 resources, increasing efficiency, productivity, and profitability of manufacturers. Now, without further ado, we'll turn this over to Dan.
Good morning and good afternoon to everyone. My name is Dan Prokopiev. I'm Chief Product Officer at Link. Many of you probably know me in person. If you don't know me, here I am on a webcam, and I will be running this webinar to you today. And just a few words about myself. So I have a manufacturing background. I would say the important steps in my career, I've spent around 6 years as industrial engineer at the large automotive plant, and then another 12 years or so I'm here with Link together with my team. We're standing behind the products that Link offers to its customers all over the globe. Right, so that's my contact details below, email and my LinkedIn profile should you wish to contact with me directly. On that note, I will switch off my video just to take it easier on the internet connection, and we'll move on. The topic of our today's session is digitalizing your factory, digitalizing your flow, and the agenda is we'll discuss in short, what is the digitalization in principle, what it may mean for you and how you can start this journey. And later on, we'll discuss manual, hybrid, and automatic data collection, which is present in Link MES software, and that's part of the digitalization we offer in the area of manufacturing operations management. We'll discuss new features and benefits available in that space. I will try to demonstrate all of that, not all of that, but high-level demo of these features in the product. And later on, we'll shortly discuss, how you can connect your particular factory, your shop floor. On this moment, I would like to ask the first question, and that is, do you have digitalizing strategy for your business? Please respond in GoToMeeting webinar control panel. We'll just give it a few seconds to go. Okay. Right. So we see that lots of attendees actually answered no, that there is no digitalization strategy in place, and well, that's a good result and bad result here. But predominantly, we understand why are the reasons, right? Why this strategy is not in place yet. And I will switch to my slide number 2. So digitalization today is it's a very important subject. It's subject on time because world is changing very quickly, as we know, but it's also part of a hype, right? We see these digitalization messages from everywhere, from newspapers, from TVs, from internet, from marketing campaigns of other companies, and so on. And all these blocks that you currently see on my screen, there are approximately 24 of them. They have direct relation to digitalization, right? Whenever you're talking about production scheduling, you may have the message that somebody would want to take your IoT data and put that into the cloud. Industry 4 is all around the globe, digital twins, and so on. And this 24 blocks is just a fraction, just a miserable fraction from all the other aspects digitalization is currently, circling around in terms of terminology and some of its meanings. We meet the customers who are a little bit lost in all of that. They don't really know where to start, because all of that, of course, requires a sort of investment, and sometimes we are talking about significant funds to invest in here. And customers need to have a proper understanding, where to start, what to do first, what to do second. I think it's important to distinguish the real from hype, because hype does exist in that area at the moment. Set your own priorities and form your strategy, and that should be your strategy. You can't simply adopt somebody else, because although we all manufacturers in here, even ourselves, because we manufacture software, we are still very different in our processes, and we might need to have a different priorities. So all these 24 blocks I would probably convert into this, talking about a manufacturing domain of the economy. Any manufacturer, one way or another, they have these 4 main pillars involved in the manufacturing process, and that's maintenance. That's really your plant asset management and maintenance of these assets. That's manufacturing operations management. That's exactly where Link sits. So that's our niche. That's our area of speciality. You also have a quality aspect of the process and aspect of the inventory management. This diagram, what you see in here, this is a so-called activity model based on international standard IEC 62264. I would actually recommend everyone to read that, because it has a lot of stuff related to proper organization of the manufacturing process, and that actually has an impact on your digitalization strategy. Right, so just a couple of words about what you see in here. So every section has some areas of responsibility in here, right? And if you were, let's say, to look into digitalizing of your maintenance part of the business, you probably would want to look into things like conditional monitoring, processing your data with AI, machine learning, do a proper digital asset management, and so on. In Link, so Link MES by itself already digitalizes your flow, your manufacturing operations, better to say, because we move your processes to a digital form. We introduce digital production plan and scheduling, dispatching of the production plan, execution management, data collection and live tracking, performance analysis, and so on. So that already is part of your digitalization. Same as your ERP system, for example, right? And in that area, we have this data collection aspect. And you are aware that at the moment we collect data using so-called workbench terminals, where employees may start their day, finish their day, report some start of the job, quantity, scrap, and so on. So another aspect of this is ability to connect data directly from the machines, right? So we may collect data from the employees, we may collect data employees reporting for the machines, or we may directly read the data from machine PLC controllers and so on. And that's one of the aspects we will be discussing on today's webinars. There are subsequent topics, of course, because if we are connecting data from machines, we can do alerting, alerting, and we have a real-time visibility to overall equipment effectiveness, overall labor effectiveness as well, because there are operators working on that equipment, and total effective equipment performance. Just a few words on the quality and inventory, right? If you were to look into digitalizing your quality aspect, probably not applicable to all of you, but to many customers it's very important topic. You may look into things like process automation. You may look into things like electronic quality assurance. You may look into things like big data, where you can put lots of your manufacturing data to a proper analysis, to uncover hidden patterns or any other aspects that may impact your quality. And excuse me, and talking about inventory, that's normally where customers at the moment, they go to RFID stock, they go to IoT track and trace, they go to inventory optimizers, electronic inventory optimizers, and so on. So take these 4 pillars, take them in mind before you develop your digitalization strategy, right? And you need to take your own decisions where you start, where you invest first. Just want to add to the to the end of this slide that this digitalization, it's not like a single one-time project, right? Something that you can start and finish. It's kind of a journey that you need to start in your business. You need to properly plan that, understand what exactly you need at this moment in time, and what to do next. And we'll hear from Link side, we're here to help you. And again, operations is somewhere that we offer you to start and go with us, right? So Link, and what we do, Link MES. This is activity model of manufacturing operations management, again, according to that standard, and that's really the main areas of responsibility of Link. So the first 2 in here normally are managed within your ERP system, and Link does the remaining 6, and that's detailed scheduling, dispatching of the schedule, execution management, data collection, live tracking of the state of the production, state of the factory, and of course later on analysis of performance and hopefully improvement of your production process. So in terms of data collection, as I mentioned, we're talking about getting data directly from machines, getting data directly from equipment, which of course is a great way because it's, first of all, it's human-less, so there are no human mistakes involved. It's real time. So as soon machine does something, we get, let's say, the parts count of if machine goes to downtime, we know immediately about that and we can react on that. We can even predict that sometimes, right? But there are multiple other softwares, and to be honest, our competitors, not competitors, I'm not even sure how to call that at the moment, but getting data from machines is not complicated stuff today. So lots of machine vendors, they offer, let's say, data publishing from the machine manufacturer today. So they equip machines and equipment with proper IoT devices, IoT hubs. You can get the data from the machine, put the data into the cloud, and so on. But what's important to understand that this raw machine data, it has a value, of course, but in order to truly uncover the value of this connected machines and connected factory, you need to put this data into the context of execution. And you really need to form what we call a manufacturing information domain. Because there is lots of other stuff around machine data, which is important, to have as offset information in here. For example, what was the job, operation, or product you run when machine went to downtime, or when machine reported some quantity, who was the employee, who was the operator, what was the execution context, what tool was on the machine, or maybe some other context, what was the production schedule, and how well you did against the production schedule, right? Maybe there were some attributes set in the ERP system that impact the process and machine knows nothing about that. So it's important to see this, even with when we talk strictly about getting data from machine, we need to think about closed loop solution where everything is connected to everything, right? Because that's really the strength of this industry for its connectivity. And within Link, we do connect machine with production schedule, with the ERP, with execution context, with everything else. Right. I will switch to my next slide, and we, in particular, will talk about this data collection and how we connect these machines. Right. So you're all aware, maybe not all, but in Link, we have, and we started, with manual data collection. So that's where we put a terminal, let's say a tablet computer or anything which can run internet browser. We put that on the machine. An operator using touchscreen technology or using RFID or barcode scanning communicates with the software, right? So with this so-called workbench terminal, an employee may select, I've started the job, I finished the job, I started the day. So employee may report data for himself as a human, but using the same tablet, employee may report data for the machine he is responsible for. So he may say, this machine is currently on downtime, or this machine really started the job. So that's called a manual data collection. Now we have an automatic data collection, and with this auto, we are able to read data. We are able to gather this data from more than 140 PLC and I/O controllers, which normally that's where you connect to read data from. And we also support all modern industrial connectivity protocols. So our connectivity ability is pretty much endless. We even are able to connect to some legacy machines, but that's a little bit of custom work, but there is this possibility of doing that. And then the last method, which I think is a key in here, and one of the unique points of Link, is the hybrid method. So that's where we can simultaneously read data from both machine, from PLC controller in automatic way, but we can also enrich this data with manual entry where required. Right, so machine may say I am in downtime, but if machine doesn't know what are the reasons behind, employee may use the workbench and specify, well, that's because there is a material shortage there. So machine may report good parts count, but machine may not know how to recognize scrap. So good parts count can be read from PLC controller automatically, but then employee may use manual way to specify, that, hey, that particular piece haven't met quality standards, that I'm putting that to scrap with a reason code X. So all of that is possible. In that sense, where you have manual, auto, and hybrid data collection, it's also important to understand when you are going to invest into this connectivity, do you need to enable all of your machines, right? Because we did, our customers, we had a customer who had like 30 machines, but only, 10 of them were critical machines for him. So he doesn't need to digitalize all 30 because that's sometimes is a big cost, right? But just 10. And remaining 20, they still report in manual mode because it's perfectly fine. It just doesn't, require much of the time, and the operator may report data instead of machine. And another 10, we are fully reading data from PLC controllers, and that goes just smoothly. Okay, so how we do that? This is a basic topology or typical topology of how we implement this machine connectivity at our customers, and that supports this manual, auto, and hybrid way of data collection. So we have a tablet, a computer, which through the network, through the local network is correct, or internet is connected to Link MES server. And whatever operator or employee does here goes straight into Link MES. Then we have machine. We may have machine 2. Machine is equipped with some PLC or I/O device. It can be anything, Siemens, Allen Bradley, whatever. It can be industrial protocol like OPC, UA, and so on. We have our so-called OPC server, which queries data from this PLC controller. Whatever schedule, 10 times a second, once in a minute, anything you like. And both of these data streams, from manual data collection, from automatic data collection, go in Link MES and form this manufacturing information domain. What we can read, just the last customer we had, very similar example. We had the machine status. We read directly from the PLC controller, and we could understand downtime, uptime, but also downtime reasons. We had the part count going also from machine PLC controller, and this part count actually was going as a cycle count, because cycle count on machine not necessarily corresponds to the part count. Your machine PLC may count the cycles, but in order to convert these cycles into the part, you may need to apply some execution context. For example, if your tool cavity is 10, in that case, 10 cycles would equal to 100 parts, right? So that's exactly what we did in there. And the last one, scrap and scrap reason, was entered manually because machine couldn't recognize scrap, and automation machine to a level where it would recognize scrap would cost amount that would not be economically viable for the customer, because they still have a operator and tablet, and it's much better for them to report that manually because they don't have lots of scrap. It doesn't take lots of time to do so. So that was the solution, and that was a success story, to be honest. Right, so features that you currently have in this Link MES when we connect machines. We are able to understand the job. Yeah, so if your machine is capable to know that, hey, I'm currently doing job, whatever, 555, right? We're able to read this information directly from the PLC controller, and we will clock in this machine into the job. So we will count not only uptime, but we will count the job time. And this machine time later on can be sent to your work in progress part of the ERP system. We're able to collect multiple jobs. So if your machine is capable to run multiple jobs, we will get this value from the PLC controllers. We will process these transactions properly. We're able to use to collect cycle counts, part counts, but also including some additional information like serial number of the product. Again, if you want to have a serial number, there should be some cam that scans serial number and puts that on the PLC, address, so we can read that, weight of the product, and so on. We're able to read scrap reason codes. If your machine can understand why the scrap is occurred. Machine status goes without saying, downtime, uptime. If your machine understands the reasons of the downtime perfectly, we will put that through into our Link MES software. You will see later on, the detailed breakdown of your availability reasons. Job operation completion status. If your machine understands that the program is, let's say, complete, so that particular operation, full quantity is produced, it's complete, we can read that. Proper status transaction will be created in Link MES. We will update your job in the ERP system that it's now complete, its operation now complete, and so on. As a result of that, you're getting real-time overall equipment effectiveness, but you also getting overall labor effectiveness, because we do relate the parts, let's say, completed on the machine and read from machine automatically to the operator who was doing the job there. Same time, you're getting total effective equipment performance, which is quite unique to Link, because not many other companies can do that, because that requires existence of production plan and scheduling. We are able to put alerting and production issues on top of this process. So if your machine goes to downtime, we will send the alert, the message to the maintenance team, to whoever is responsible for that machine. We can create a production issue, so it can be assigned to the person for the resolution. Again, later on, all production issues will take part in the either availability or performance breakdown analysis. We have instant ERP integration. Anything counted in here as a part count instantly may go to your work in progress and update corresponding jobs and operations. Error handling, very important topic when you talk about reading data from machines, especially if you are in a high-speed production lines, right? Your machines may produce, thousands or even tens of thousands of transactions per day or even per hour. If something goes wrong and some wrong data is coming in, you need to have a proper ways of handle these errors, right? You need to have ways to distinguish these error transactions and to correct them in the most efficient way. We are able to generate so-called time series data for conditional monitoring. I mean, this data has no direct effect to OEE or TEEP because it's pretty much not impacting availability, performance, or quality metrics, but still this is important conditional information that often our customers want to see live or analyze later on. So we have ability to bring you unlimited number of these data points, from multiple machines. We'll log that either to your SQL server or we can send it also to the cloud. And that can be anything. So this can be temperature, this can be vibration, this can be pressure, spindle speed, whatever else, you name it. And then of course, last but not least, all these facilities, to collect data from machines, they have now open, publicly available REST API that you can consume. You can create your own solutions in that space. You can connect other software. What we also did, which really proves its point, we also did so-called SQL middleware. So we put like a table in our database where you can, either manually or in any other way, you can just put a machine data into this table and we will understand that and we will process that properly. And this database has a very simple form. It has a form of this, in connected machines world, there is a term called tag, and we'll talk about that slightly later. So it's like a tag value, like temperature, value of the temperature, and timestamp where it occurs here, or parts count, value of parts count, timestamp where it occurred. Okay, so I will move on, and right now I would really love to show you the actual software because it's always better to see than to listen. And what we'll discuss today will go to signals and processors and what that means. We'll talk about use of multiple data points, so-called tags. I'll show you our brilliant factory automation simulation and how you can use that. We'll again discuss this manual, auto, and hybrid data collection options. We'll go to live tracking and loss analysis. And on this note, I will switch my screen to our server. Give me a second. And here I am. So I hope you can still see my screen. So this is Link MES. It's a web-based software. It's a landing page. And data collection, we start really data collection with our seat maintenance, or that's the place where we configure this data collection to your equipment or your machine. And I have a machine which is called MBFA 01. And you would see that there is a section here which is responsible for automation. I should enable that, of course, because I can enable or disable that based on the machine I would want to work with. You specify some key data of, what's the model of the machine, what type of PLC controller. In my case, it's virtualized Siemens controller, IP address to that controller, and so on. That's pretty much all we need. Then our software will automatically connect to this controller using the right drivers or industrial protocols to read the data in. Then there is a tab called automation, and there are 3 subtabs: signals, processors, and monitor. So what that is and why we need that. Yeah. So your machine, depending of the level of its enablement or so-called digitalization, it may have multiple data points. And these data points, it's exactly what it is. So if there is some information, let's say a machine status, or the part count or whatever else, there is a data point behind that. And this data point often is called a tag. So within these signals, we are creating a signal which is really a reference to that data point in the PLC controller. And we have signals of these 5 types. So that's resource status, good quantity, scrap quantity, active task, and task status. So if we want to, let's say, get the resource status from the machine, I'm creating a resource status signal, and I'm pointing this signal to this unique tag identifier of this data point on the PLC controller. Of course, there are multiple other options in that signal, because this tag may give value of different types. It can be incremental increase, let's say, of the parts count, or it can be non-incremental increase, and there is different formulas to process the data, but we'll not go to this level of detailization in this demo. But essentially, what this signal does, it reads the data from the machine and then passes this data to a processing. Same time, it analyzes the data for its validness. Yeah, because let's say if you had a parts count on the PLC controller of 500 pieces, for example, and the next second it become 10 pieces, so there was a drop of 490. What's that? Is it a mistake in the PLC controller or whatever else? So you have this mechanisms to analyze the incoming data to distinguish whenever it's something you need to process or just ignore. So that's also another duty of a signal. So then we are going to a processor. And what processor does, it converts this machine data signal into link MES language. Because it's link MES, it's not a raw data, as I explained. There is lots and lots and lots of contextual information. What is the job? What is the current task? What is the expected runtime of that task, and so on. So processor does this option. And then we have monitor, which in real time, if it's enabled, shows how the data is coming in from the PLC controllers, and that often helps in the process of setting up the PLC controller and in the process of troubleshooting if it's required. So now I'm actually going to show you how this factory automation works, and I will run this simulator that we have in our software. So what you have in here, you have a line, and this line produces boxes, and this line has these tags. Yeah, so this signal, so it has active task, good quantity, serial number of the product we produce, scrap quantity, scrap reason code, status of the machine, and some temperature. So what I will do, I will say, hey, on that machine, I'm starting the job number X, let's say operation 2, and I'm hitting start button. So as you see, this monitor shows that machine already starts the job, but it's currently in stop state. So as soon as I click start button, machine will start to produce these boxes with the speed of 3,600 units per hour. So that's 1 unit a second, and my good parts count is growing. Every time the orange box comes in, my scrap information will go. Here on the tag, so that's exactly what you would see on the PLC controller. You see active task, you see good counter increasing, you see serial number, which is like a timestamp changing every time part is produced. Then you see scrap and scrap reason code. It's currently overweight, that's for that box. And you see state of the machine, which is running. And then you see the monitor of how this information flows into the system. I can change, that, let's say, to be 10 units per second, and you see it's, it processes at the moment quite a high number of transactions, and we can, really read thousands of or even tens of thousands of transactions per hour. But I will stop now, switch to some other speed, and my machine is running. It's green. What I will do now, from the supervisor perspective, I will go to my equipment status, and here is my machine. I have a couple of jobs there. So another job is started on another PLC controller. I see my parts count. I see that there is KPIs updated immediately there. My green indicator in here says, hey, my valid data is coming. Well, when I was preparing to that session, I created a couple of downtimes on that machine. So system automatically generated for me alerts for the supervisor that machine was in downtime, and also production issues, which I can access here, and assign to somebody to resolve. If I go back to my simulation and let's say I'll put that to stop, so my stop monitor will come. If I go back to my state, I would see this machine is currently on stop, and that happens instantly. From the operator standpoint, and in here I will talk a little bit about this manual and automated data collection. So if I am an operator and I'm back to machine, I can see that this machine is currently in downtime, right, on my tablet, on my computer. But I still I can report some additional data to that machine. I can restart that machine directly from here, even without PLC controller, for example, connectivity dropped or whatever else. I can specify what is the downtime reason, because at the moment it went just to downtime, which is converted by processor to general breakdown, right? If I restart that machine again, and I'll go to Workbench, and I refresh, I would see this machine is again running, and I can see the parts count against my jobs. And as I mentioned to you before, even if we do multiple jobs on the machine, we are able to process that, and we have mechanisms to split the quantity that comes from the parts count PLC to one or another job on that machine. Right, so that was an element of manual, hybrid, and automatic data collection. So just to repeat again, actual job or multiple jobs, if your machine can do multiple jobs, good quantity, scrap quantity, additional information like serial number, like scrap reason code, machine status, with status breakdown, and conditional data like this temperature, which is currently 22 degrees Celsius. I'm not sure what's that in Fahrenheit, unfortunately. Right. What I will do now, I will go back to my equipment status. I still see my OLE, my overall equipment effectiveness. Here it is. I see my total effective equipment performance. Same time, I have the metrics to my employees. So that's my operator, and that's his KPIs that are completely driven by our connected machine. And this data coming in impacts his performance and quality metrics, giving us overall labor effectiveness. Right, so as I mentioned before, on top of that process, we can put alerts and production issues, which in real time will analyze how this process relates to expected throughput, right? And if there is, let's say, the downtime or speed is, the speed of production is higher than it should or slower than it should, we can immediately create alerts to corresponding people, and notify them, that something goes wrong. In this section, we have in factory automation section, we can see all the data that comes in from the machine. We of course have the separation between errors, transactions, good transactions. Should there be any issues, in here, I have all the mechanisms to qualify these transactions and to correct the transactions with either bulk edit or single edit types of operation, and so on. Right, and last but not least, besides the live tracking and live analysis, you have immediate effect of your loss management. So if your machine reports the data, you immediately see, how your loss management picture happens for that machine during that day. So I see my availability reasons. So machine was in tooling failure downtime read automatically from the PLC controller in unplanned maintenance. I see my performance loss and where it came from, equipment wear, component jams. That's probably data reported manually as a hybrid option in the workbench. And I see a quality loss again coming from the machine. And that's pretty much scrap reason codes it captured in the last couple of minutes. Right, on that note, I will switch back to my slides. And we just passed that quick demonstration, high level, but I hope you enjoyed that. And the benefits. So what it gives us, ability to connect machines, ability to have all of that as part of a closed loop solution in Link MES. That's digitalization. The whole idea is to drive your factory performance. And how to do that? Well, you need to improve visibility across manufacturing operations. You can make more informed decisions with a real-time picture of your operational status, especially if you talk about machines and machine state, because normally machine hour is quite an expensive hour, and any downtime there really has a high cost and high effect on subsequent production flows. Improve effectiveness, because if everything works as it should, its issues are prevented, you are maximizing equipment availability, performance, quality, and as a result, efficiency and total effective equipment performance. By doing that, you're reducing your cost of production because you eliminate loss, right? You can see the loss immediately. You can gain this intelligent analytical insights that we provide, and you optimize your production to eliminate this loss. You are reducing time to market. Again, by analyzing what's happened, you can fine-tune your production processes to build more optimal manufacturing flows. And in the end of the day, you increase your factory performance. And that's, again, I can't stress more that it's very important to have a closed loop solution, unique manufacturing information domain, which starts from planning, goes to tracking, data collection, automation of data collection, analysis of this data, and hopefully optimization of your production flow.
Full screen.
Right. So I just forgot to make it full screen. Sorry for that. Right. On that note, I would like to give you the question number 2, to ask question number 2. How many machines do you think could be automated in your business? It's still collecting. Just give it another few seconds. Right, so we have actually very interesting results in here. So we have approximately 50% of our audience to be 5 to 15, 5 to 20, and another 50 plus, which is very good, which means there is a lots of potential in digitalization on both sides in here. We have quite a few on 1 to 5 and 20 to 50. Thanks. And now I would like to ask you question number 2. When are you looking to automate the capture of machine data? Okay, very good. All right, so I think everyone would be interested to know the results. We have approximately 50% on the option of not sure, and then another 50% evenly split between these 3 options. I assume this option of not sure is again related to a missing digitalization strategy in your business, right? And of course that explains. And I hope this webinar will help you take the right decisions. Start to think what areas you would like to do. To do this digitalization first. Because again, this digital transformation is a hype, but it's not just a hype. I think it's just in time where you need to look into that as a small to mid-sized manufacturer. We know that the bigger companies, more fortunate businesses in terms of the volume, they are already in that path for years, and the small to mid-sized manufacturers always were a little bit behind in that space. That was related to the fact that the whole technology was quite expensive in that area. But today it's different. Technology cost in that area lowers down day from day, and I think it's all becomes very, very possible now. And that definitely will help you to stay competitive, to be competitive, and to drive your factory performance. Just a few words about future roadmap. We are going to publish our roadmap in 2021. Besides all the other software improvements in multiple areas, there definitely will be a place for a future connecting machines, factory automation, and digitalization aspect. One of them would be will enrich conditional monitoring functionality, to have more functional coverage in that space. And conditional monitoring again means data related to the procedural state of the machine, like temperature, again, pressure, spindle speed, whatever else. And you will be able to connect your machines, which are of course on site, to our Link Cloud, which will make available as Link MES SaaS initiative in 2022. And again, even if that's a cloud, you still will have a full manufacturing data domain there, not just the raw machine data. On that note, thanks for listening, and I would like to go into sections area. And if you have any questions area, if you have any questions, please ask them in GoToWebinar control panel.
Dan, just because we're running out of time now, a lot of questions. We'll try to get back to everyone individually after the event, but there are a couple here. We can do 2. I've got one from Joe. Joe has 5 CNC machines that have Allen Bradley PLCs on them, and wants to know how long does it take to connect those machines with Link MES? What's the average?
Thanks, John. Thanks, Joe. So connecting to machines consists of 2 sides, 2 aspects. First of all, your machine should be enabled and should be digitalized, right? So let's say if you want to get the machine status, There should be, some PLC controller, maybe some sensor who reads the data and makes this data available on the machine. So I assume this is already done in your environment because you have CNCs and Allen Bradleys. These are sophisticated machines. If it's not the case, that's normally is responsibility between customer and his machine vendor or machine partner to digitalize that machine to that level. Once this is done and machine has the data available, it's really a matter of an hour to get Link MES connected to that machine. Allen Bradley is something we support out of the shell. We will just configure signal, configure processor, and get the data in. And normally, we charge 1 hour of service time per machine when we, talking about connecting machines.
Just on that note, everyone, there is a handout there which provides a list of all the PLC controllers that we can connect with. Just one other question, very quick one from Steve. I have a customer that may be interested in factory automation. How do I schedule a demo? Oh, that's definitely one for me. If you can go onto our website, there's a button to schedule demos. Just click on that button, fill some details in, and I'll be in touch, and we'll have that call with you and potentially with your customer. So appreciate that. For those questions that remain unanswered this evening, we'll get back to you in the next day or so with questions. This is going to be recorded, and we will be making this recording available. It will also be backed up and made available on our website. Just a quick reminder that we've got a webinar running on the 18th of November from 1 p.m. Eastern Standard, and it's regarding maximizing output with effective scheduling. So for those of you that are interested in planning and scheduling, improving the optimization of your resources, order fulfillment, their scheduling, then that's a good one to attend to. That's Wednesday, the 18th of November at 1 p.m. So really appreciate everyone's time. Dan, great demo. Thank you very much for everyone attending tonight and today, and we'll look forward to speaking with you all again soon. Thank you.
Thank you very much.